Alright, welcome back everybody. My name is Dustin. And in the last video, we added the play and stop buttons to the editor. So now we can reset the Lua state and reload the script without stopping the editor as well. So that's great. So now if we want, we can make changes to our scripts. And instead of shutting everything down, we just stop it and then replay, and those changes should automatically be loaded for us. So in this video, it's going to be all Lua. Well, hopefully all Lua. We may have to make some engine changes. I'm not sure yet, but we'll see. So we're going to create the projectile class and the projectile defs. And the goal for this is to be able to fire off projectiles for the player. So let's see how we have our shooting animation here, but we have nothing coming out. So that's the goal for today, is to be able to fire off the projectiles and be able to control them and control their life and stuff like that. We're also going to want to add some sounds and other, so sounds just for shooting the projectile and maybe some ambient music as well. Okay, so let's get into it. So we can actually stop this. We don't have to actually shut it down anymore. We can actually just go from here. And what we're going to want to do is go to our Scion editor and go to our scripts, go to our platformer, and we're going to want to add some new Lua classes in here. And just to keep everything nice and clean, let's make a new folder, add new, and this will just be projectiles. And inside of projectiles, let's add a new, and it'll just be projectile.lua. So if you made it this far in the series, you should be able to make a simple Lua class by now. So it's just projectile is equal to, then we want to say projectile.index is equal to projectile. Then we want to do our create function. So it's just function projectile create, and that's going to take in some parameters. And we're going to have our local this is going to be our member variables. And what we're going to have is our definition. That's just going to be params.def. Then we're going to have the direction, params.dir. Then we're going to have our start position. Where does the projectile start in the world? Params.start. Pause, rotation, params.rotation, or 0. Projectile is just going to be an entity, so we need to have a folder for the entity ID. So entity ID is equal to -1. And lifetime, so how long do we want the projectile to live for, is equal to params dot lifetime, or let's say 500, and it's going to be milliseconds. Okay, and we're going to have the life timer. That's just a new timer, and we want the speed and speed. That's going to be params dot speed or 1000. Now we have to take in delta time into effect here. So that's going to be adjusting this accordingly. Cool. And that should be good for now for the member variables. So now we're going to want to get the projectile itself from the definition. So we want to get the def. So we want to go local projectile. So what is the projectile? And that's going to be, we'll say projectile def is equal to projectile defs. We haven't created this yet, but we're going to have to, and it's going to be this dot mdef. Okay, so what this is, it's going to be a table, and we will hold all the definitions based on the def, and the def's just going to be a name or a string, right? So just the name of the definition. I did not spell that right. And projectile defs. Cool. That way we're not actually holding on to the def itself. We can just grab it based off its name. So we're gonna have to create this later, but we'll get into that. And then we're gonna want to assert that projectile depth is there. So we'll say projectile depth. We want to say failed to get projectile depth. Now, I believe we did an override for the assert. Let's go take a look at the signature we did for that. And that was in the Scion core in the systems, scripting system. And let's just go assert. Yeah, right here. So it takes in our argument to check in the message and then some arguments, variable amount of arguments if necessary. So we can actually add that in as well. Fail to get projectile depth, and let's just put this in brackets here, and it will say this dot and def. That should work. If not, we'll fix it. So we're going to want to set the physics position or the physics attributes position based on the position that we're sending in. So we're going to want to say projectile def dot components, because it's going to have a components, and it's going to have physics attributes dot position. And that's going to be equal to this dot and start. And the start position we'll be sending in. So anytime you send in, you create a projectile, you need to send in the position where you want it created. Okay. And then we'll say this dot entity ID is equal to load entity. Load entity is a utility function that we created previously, and it's going to take in the projectile. Okay. So projectile depth, sorry. So basically the projectile depth that we get from projectile depth needs to match the signature or match the ability, whatever we're doing in load entity. Okay. And then now that we have that, we can go local projectile ent. So proj ent is equal to entity. We want the actual entity now because this is just returning the ID. Now I want to get an entity object. Okay. Is equal to this dot entity ID. Then we want to get the transform and set the transform to the start position. So local transform is equal to proj ent get component transform. Cool. And then now that we have the transform, we can go transform dot position is equal to this dot start pause. And we can say transform dot rotation is equal to this dot rotation. And now that we have that, and it should be going where we want it, or should be created where we want it to be, we need to start the timer. So we can go with this dot life timer start. Cool. Now that we have that, we can set the meta table, set meta table, this and self. And we're going to want to return this. Cool. That's the start of our class. If we need to add more things in, we will. All right. So what else we're going to need? We're going to need an update function. So the update function is basically going to take the projectile and update its position. Okay. So that's what we need really. So we go function projectile update, and that's going to take in DT or delta time. And so we're going to want to go local projectile is equal to entity self.entity ID. So we're getting the projectile entity. So this should say projectile and we'll just say projectile. Now we want to get the physics component. So we can go local. Let's actually make this a bit larger here. So we can say local physics is equal to projectile get component, and we want the physics component, physics conf, I believe that's what we call it. Cool. Now for these particular projectiles, we're only going to move from left to right. However, we will adjust this later on to be able to move in multiple directions. But for now, I only care if it moves left or right. Okay, so I'm going to want to go physics dot set linear velocity. And I'm going to want to go vec2 and that's going to be self.mdir. Now mdir in this sense is just going to be, is it going left or right? So it's just going to be a single value, and it's going to be multiplied. So the value is going to be negative or positive, okay? So times, sorry, this should be mdir times self.m speed times delta time. And that's for the x, because I only care about left to right now, and then just 0 for the y, okay? Cool. So we have another function, and it's going to just be called the times up. So we'll say function projectile times up. And the times up function will just be a simple function that returns true or false, depending on if the elapsed time is greater than the projectile's lifetime, right? So all we do here for the ending is go return self.m lifetimer elapsed, we're going to use milliseconds here, is greater or equal to self.m lifetime. So that will return true or false. Cool. And we're also going to need a destroy function that will kill the underlying entity. So the destroy function will just call the kill function on the projectile's entity here. So we'll just go through function projectile destroy, and we'll say entity self.m entity ID, and we can call kill directly. Cool. And I think we can just add a little log here to say that we killed it or not. And let's see, I can't remember what we called our logs. It's error or warn. We'll say warn. So S2D warn. Cool. And we'll say killed projectile with ID. And we can do, I believe this will work. And then send in self.m entity ID. Cool. And that should be pretty good for now for the projectile class. We can add in more functionality to the projectile class later on as we need it. But for now, but now that we have that, now we want to go and actually create the new Lua table for the projectile defs. This will be a table that holds all of the projectile definitions, so we can easily grab them when needed. It'll be this table here, okay? We want to be able to grab the def by its name. So let's create a new file in our projectiles folder. So we can close it. We don't need that right now. And here, so add new. And it's just going to be projectile defs.lua. And we need to create that table. So projectile defs. And that's just going to be a table. So the projectile defs are going to be pretty straightforward. A projectile is basically just an entity. So what we need to have here is all the necessary components and other data that we may need, like lifetime, speed, etc. All right, so this is what we're basically going to be using this. I called it the shot atlas. What I did is I grabbed these off of OpenGameArt. It actually looked more like this one here, and I just adjusted them for our game. So I just made them so basically it was just one image, and I changed its size, changed its shape, and just moved it around. So this is going to be the big shot or the power shot if you're facing based on the direction you're facing, right? And these are going to be the regular shots here. So we're going to use this, or you can go up to OpenGameArt and grab whatever you like. These are the ones that I grabbed. And I just made this in A-Sprite, and I left it big like this. I think this is 512 by 512. Let's take a look. Yeah, 512 by 512. So I can add in more projectiles as needed. So this is our shot atlas, but I did grab these off OpenGameArt and change them to work for me. This was actually a huge picture that I got the idea from and shrunk it down to fit into a 32 by 32. I think it was huge. I think it was like the size of this. And it still ended up looking really nice. I had to make a few little adjustments, but it worked out well. So that's what we're going to use here. And let's go back to the definitions. So the first one we're going to do or care about is the regular shot. We'll get into the bigger shot later. So regular shot is going to be the name of it. And we'll just create another table. And it's going to have a tag. And the tag is just going to be regular. I will say regular shot. And it's going to have a group, and its group is going to be projectile. Projectile. And then we're going to do our components. Now we're going to have a transform component. Transform. It's going to have a position. And the position is just so we have it. It's just going to be 0, 0. That's going to be a vec2, 0, 0. Then we're going to have a scale. It's going to be vec2, 1, 1. Then we're going to have rotation. And that's going to be 0, 0. Cool. Then we're going to have a sprite component, sprite. And that's going to be another component here. So we're going to have our texture is equal to shot atlas. We're going to have a width. And the width of this is 32. And the height is also 32. That's the thing about creating your own sheets. You can sheet them out however you want, right? Like this definitely doesn't need 32, but I'm giving it 32 so I can easily go through this atlas. So each one is going to be 32, and then I just adjust accordingly based on its position, okay? And that's what the definitions are for, so we can make the proper adjustments that we need for our colliders and stuff like that, okay? And, oh, let's bring that back over. So we're going to have our start X and start Y. So if I come back here and bring this, show you this. So the start X is going to be starting at 0 for the small shot. Now we could have a left-right small shot because it does kind of fade a little bit to that direction, but we'll just leave it for now. The start X is going to be 0, but our start Y is going to be, it starts at 0, 0 here, 1, 2. Okay, so 0 and 2. So start X is equal to 0. Start Y is equal to 2. And then we're going to have a layer. We'll just put this at layer 3. Layer is equal to 3. Cool. Now this is going to have an animation, and it's going to be animation is equal to the new table. And it's going to say num frames is equal to 4. Frame rate. And we'll put this at 20. And frame offset doesn't have a frame offset, but put it in anyway. Frame offset is equal to 0. Is it vertical? No. So we'll say B vertical is equal to false, and B looped. We'll say true. We want it looped. This is going to have a circle collider. Circle collider with a radius of, we'll start at 8. I know 8 is going to be huge, but we're going to start at 8. And we're going to give it an offset. And that's going to equal to vec2. And that's going to be 8 and 12. We can change that accordingly. And now the physics attributes. The physics attributes are actually what is the hard part here. So we can go type is equal to body type dot dynamic. Density, we'll just have that equal to 1.0. Friction, did I spell that right? I think so. It's equal to 1.0. Restitution, and that's going to be equal to 0.0. Restitution is the bounciness. We don't really need this to bounce. The position, and that we can just set that to vec2 0, 0 for now, because the position of this particular projectile gets reset inside of the projectile component here, right? And the position gets set before it's created. So the position, and then we're gonna have our radius is equal to 8. Then we're gonna have B circle equal to true. B is sensor. And yes, it is a sensor. We want these to be sensors. We just want them to go through everything. We don't want it to have physics properties where it's bouncing off walls and stuff. We want to go through walls and only trigger it if we need to trigger it. And we'll do that in the trigger system. B, fixed rotation. Fixed rotation. That's true. For this particular projectile. You can also create your own projectiles and stuff. Yeah. Oh, I forgot to do something here. You guys probably caught this already. I just started going on top of this. But we actually want to say physics attributes table and grab. this. Put that inside. Because that's what our load entity is expecting. It's expecting these all to be in the physics attributes table. Cool. And then we have our object data. That's another table. And we're going to say tag. And then we're just going to call the tag shot for now. And no group. I guess we could put projectile as well. Projectile. That's not going to hurt anything. B collider. Is it a collider? No. False. Is it a trigger? B trigger. It's true. It is a trigger. Is it a trigger or is it just a sensor? We'll get into that. Leave it a trigger for now. And B is friendly, or B friendly, I think we called it. Friendly. We'll check. And this is friendly. We don't want this to hit the player. All right, that's good for now. And we do have the charge shot, but we're not going to get into that right now. Just do the one shot for now, get it going, get it working. Great. So now that those are done, let's go to the player's move class and get these going. So up here, go back into, we're still in our scripts. Go to, where did we put those characters? Yeah. Player states, move state. I think we started it. Yeah. So we started this here and we added this shoot projectile function. I don't think we actually made the function. Let's take a look. No, we didn't. So we have to make this function. So we'll just do that at the bottom here. And that's going to be, what we call this just move state, I believe. Here in, yeah, move state, take this, go down and say function, move state, shoot projectile. Now, right now, we're not caring about what type of projectile it is. We're not sending any params and stuff, but that would be based on the character, and you'll have to add that in later. So we'll have our character class to go back to the character itself. You can have what weapon it currently has now. You can have that as a variable and have it as, so what am I currently using right now? So it could have different shots, different types of weapons, different strengths, different things like that. You're going to have to change that and add that in. So we grab it from the character to choose what projectile to actually shoot off. Okay. So the shoot projectile is pretty straightforward. We can say local player is equal to entity. So we basically just want to get the player. Self.m entity ID. Then we say local transform is equal to player get component transform. Why do we want the transform from the player? Because we need to shoot it from the player. We need to set the projectile position based on the current transform or the current position of the player. So right now we'll say local proj dir projectile direction is equal to 1. And we say local position is equal to transform dot position transform dot position. Okay. Then I want to say if self dot m character dot m be facing left. So if we're facing left, then I want to set my projectile position. So I want to say projectile position and its direction. Dir is equal to -1. Then I want to say position is equal to position plus back to 8 and 16. These are some values I was already tinkering with. Else, if we're not facing left, we don't need to change the proj direction because it's already there. But we can take this here and adjust this accordingly. So we need to change this to 24 and 16. Cool. So this will change the position of the projectile based on the position of the player. So now we actually want to create the projectile. So we can go projectile, create, and we're going to add our params here. The params is just a table we're sending in, and it's going to have a definition. And the def, we're going to look for a regular shot. Remember, we're going to change this later as well, so to change the def based on what the player or the character is currently equipped with. But that's further ahead. So regular shot, and we're going to say dir is equal to proj dir. Then we're going to say start pause is equal to the position. And lifetime we can set to 1,000. So lifetime. Let's make it 1 second. So 1,000. Cool. All right. So now we have to go and add these 2 new files to our script list right here. We need to add these in. And we need to do them before the move state because the move state needs to know about these. So we could probably put it right here. And let's just copy this line down. And it is platform. It's not utilities, it's projectiles. Projectiles. And we'll have projectile defs, because projectile calls projectile defs. So projectile defs.lua. Projectile defs. I believe that's correct. Copy this down the line and just change this to projectile.lua. Cool. That should work. If we have any errors, we will see right away. So if we open up our game and we just go start, and we'll bring this to the top, and we're already playing. Let's go in. So right now we're trying to hear this snowfall sound. Let's get rid of that because it's causing an issue. So let's fix this here. So it's rain and snowfall. So it's trying to get these sounds, and it doesn't know what they are. Okay, let's clear this. Clear that as well. So let's go into wherever we're setting those. So for the rain, I think that's in game state, title state. Where are we setting those sounds? It would probably be in an on enter function. So not that, so it must be game state. Yeah, right here. So we don't need any of these. Well, we can leave those there, but let's just comment them out for now. Cool. And we go back into the game itself. Start it. So we're still, yeah, these are going to load because we've already have those loaded. So let's clear this so we can see any real errors. Cool. So snowfall, it's like it's not reloading the way I thought it would. My script list. Oh, no, it's doing exactly what we're telling it to do. I feel silly. So it is reloading it. The problem is actually in our asset devs. We're trying to load these, but they don't exist. So we can actually take this right, well, we'll keep that, sorry. It's the, yeah, we're not even, wait, hold on. Maybe I'm wrong again. We're not even loading any music. Where's these sounds getting played again? Maybe our Lua state's not being reset, but we'll figure that out. Let's go to main. Loading the script list. All right, so what I want to do now to make sure that this is actually loading itself, let's just do this here. And it should give us a proper error that it's not loading the script list. If it's not, then we got to figure out why it's not actually reloading. Because it should be reloading, and then I made a mistake somewhere. So let's go stop, start. Yeah, it shouldn't even reload. Stop, start. So my stop start is not working the way I want it to, because it shouldn't even reload this because my script list. So right here when I hit stop, it should have actually cleared the state. So let's go in and take a look at the code. Because if I stop it now and run it again, now it should break because it's reloading everything, but it should have reloaded with the stop start button. Yeah, so we have errors here because it doesn't know what all this stuff is. Doesn't know what the script list and all that is. So that's my fault. It should. So we're missing something here. So that would be in our editor. in our assets. So it's editor, displays, and scene display. So we should be reloading everything. So when we load the scene, easiest way is put this back in debug and do a quick build. All right. So if we go and place a couple breakpoints, let's place one right here. It should eventually hit that because we should be resetting it here. Go back in. So run, stop, run, and it does hit because it's empty. Cool. So we ended up with some errors here. So shot atlas was not created because we didn't add it in yet. And that's fine. So I got to figure out why it's not resetting the way that I want it to. It's not resetting my Lewis state, which it should. So let's add in a log in our main just to make sure. So let's go here into main.lua and then just say s2d log reloaded. Let's see. So we're not shutting it down, and I want to see if that shows up here in my logs. Stop, play. No, it does not. Clear. So stop, play. It does not, but it should. So I'm gonna have to fix that. So we need to add in the shot atlas. So that's what we'll do right now. Add that texture in. So here. So I've added that back into our assets, the shot atlas right here. Now I added it in, but it should work. So let's start it again. Go in here. So yeah, so shot atlas was not created. That's because we didn't change it in our asset devs. So let's add the shot atlas into asset devs here. So we go to our asset devs and add in another one. So we'll just say, copy this down, should be the same place. We'll say shot atlas, shot atlas. And when we restart it, it should actually work. Yeah, so I'm not sure why it's not doing that. I think it has to do with the files not being copied over. So let's actually close this for a sec. And if I restart it, it re-copies the files over, I believe. Let me see. Go back here. Where was it? So I think that's what's happening. So with CMake, what it's doing, it's recopying the files over. So if there's any changes, it's recopying it over. But if I'm running it in a solution, it works fine. So I think it works the way it should. It's just the fact that CMake has to copy it over any of the changes, right? So if we were making the changes, so in wherever the CMake is running this executable from, so it's running it in bin scion.exe. So if I'm making the changes while it's running, it's not actually copying the files over. Does that make sense? So let's open that folder path up real fast. All right, so it's right here. If we take a look here, we have our bin folder here and our assets. So these have to get copied over. Every time we make a change, it has to get copied over. But if I'm making a change in here, these files are just in our build folder. So that's why it's not getting copied over. It has to be copied over. Does that make sense? The stop and start is not going to work while we're running in the editor like this. we need to run these folders. So say we open up this here as an executable, right? So if we open up, we have our binary and we run this as an executable. We should be able to run this from here, our Scion editor. We're running it in the debugger here. If you look at it, this is our out build. These are different. So we go back here and go back to the Scion editor. These assets are different assets than the ones that we have in our out folder. Okay, so here in our out, build, debug, or whatever we're running, bin, these assets are different. They're copied over. Every time we run our build, it copies it over these assets, right? So, and eventually we won't be running it from the debugger like this. We won't be running it like that. We'll be running it from an executable, okay? So if we go back to our binary and we run it from here, we just run the executable. It should all boot up the same way. Yeah, you see here, and it's running, it's everything that we had, it's the executable, correct? So eventually we'll run from the executable. It's reading these assets. However, we're not making changes to these assets. It's getting copied over from these assets. So we'll just keep doing that. We're gonna have to keep stopping and starting in order to get this to work correctly. But it is working. So my stop start is working. It's just working on incorrect assets because the assets need to be copied over. And our CMake is what copies the assets over every time we run a new build. Okay. So we'll just ignore that for now and we'll just keep doing the build. So let's run it here and let's fix any other problems. So if we run it now, see it says reloaded because it actually did reload. And we're running it. So we're just making these black boxes, right? Which is fine. And you see how they're just dropping wherever? We can actually take this out of debug mode because it is working. So let's put this back into release, which is much faster. The reason debug is slow right now is because we have all that rain going on in the background. If we turn the rain on, it would be running quite quickly. But you shouldn't be running in debug anyway, unless you're doing exactly that, debugging. So failed to load the main script, right? Because it didn't copy them over. That's because we made those changes. Don't know why this is unhappy now. Release, run. All right, make a little change there, see if it copies them over now. Still unhappy with release. What did I do? Let's go back to main, Lua. Sorry guys, let's get rid of this. Shot atlas.png, unable to open file. That's good. 16, so it's not open title state, and that's fine. So that's probably our cache is not built up. So let's go to, where is that again? Not rebuild, configure cache. Try running it again. Cool. Yeah, so CMake has its little changes and nuances that I still am getting used to, but now it should work. And there's our projectiles. Awesome. So you see how they're just falling? That's because we're not updating them. So we created the projectiles here, but the game does not know how to deal with them. So what we need to do now is to create something that keeps track of the projectiles and updates them for us. Right now they're just falling for wherever, and they're actually not dying. They're just there forever, and they just fall through everything, okay? So we need something that also removes them after their time is up. So for that, we can just create a table to track them and update them in the game state. So let's add the new table and some functions inside of our utilities file. Okay, so let's close this. I wonder if we can redo the cache while this is running. That will save us some time. So we'll go here, go back into this here, and let's open up our utilities.lua. So that's in our editor, scripts, platformer, utilities, utilities.lua. And we can treat the projectiles just like we treat the active characters table here, and just update them and remove them accordingly. We could also change both of these, the active characters and the new projectiles table that we're going to create. We can change those both into their own classes if we like the character manager and the projectile manager classes, and place them into their Lua files instead of them being here in utilities, we could do that instead and call them accordingly. That actually could be a little challenge for you guys if you're up to it. If you made it this far in the series, you definitely should be able to do that. Just create 2 new simple classes, Lua classes, and call them in the game state. Give it a shot and let me know in the comments if you need a hand. All right, but for now, we're just going to do it this way. And if you want me to go over how to make them into Lua classes, let me know, and I'll go over that in the next video. So for now, let's just go right here and add in a new projectiles. And it's just going to be a table, empty table. It's basically a global table function. And then we go add projectile. And that'll be projectile. I'll take in a projectile. And then that'll just be the table projectiles at projectile.entity ID. That's going to be the key is equal to the projectile. Cool. Now we're going to have a function to update the projectile. So that'll just be function update projectiles. And I'll just take in delta time. And then we go for k v in pairs projectile do. Then we want to say put the end, might as well put the end, and then do we want to say if v times up, then v destroy. So, and v is the projectile. And then we also want to take out the projectile from projectiles table. Projectiles at k is equal to nil. If we don't do this, it's going to stay in there and it may try to use it after it's already been destroyed. So we got to make sure that we take it out of the table. Then else, so if the time is not up, we want to just update. v.update dt. And cool. And let's create one more for resetting. So function dot reset projectiles and for this one we just want to go for v in pairs projectile do, and so I just need to go, I guess we could just use k here. Then we can just go entity at v.m entity ID, or actually we can just do this. V destroy and projectiles at k equals nil. And that all that is just looping through and getting rid of all the entities in the table. Cool, now that we have a way to keep track of the projectiles, let's go back into the game state and add that in there. So if we go to game state here, and right after update active characters, we can say update projectiles dt. So now we have updated projectiles, but we're not adding them in yet. So we got to go back into the move state and add in the projectile. And we'll do that here. And we just say add projectile. That's it. That's all we need to do. And let's try to update the cache right now without shutting it down, see if that'll work. So project. No, you can't configure the cache while it's down, so we got to stop it. Start it. That should do the cache for us, I believe. We'll see in a second. Yep. Awesome. And they're dying. Beautiful. Now we're getting some errors here for bad anycasts, but ignore those. We can actually comment that out for now because we can just eat that, because what's happening is when it's going through the contact listener, it's trying to cast something, but it may have already been deleted inside of the world. So it may have, and so it's trying to cast something that was already deleted, but we're catching that anyway. Okay, cool. Awesome. So it is slowing down, so we got a problem here. So let's figure out what that is. Yeah, it's to be spiked in memory like crazy. We can't have that. Now it's all gone. It all went back down here. But wow, did it go high. And we got to figure out why it's doing that. And it's probably all the checks that we're doing. So let's get rid of that cast for now. Not the cast, but the error in the casting. So let's go here, go to our physics and source, contact listener, and we have our cast, fail to cast. Let's just get rid of that for now. Same with this, get rid of that for now. And we'll just eat this. Eat this exception for now. Same with this one. Is there any more? Okay, so let's run this. And we'll run it. And we'll just shoot. And yeah, see it's slowing down. Let's check our memory out. Oh, memory didn't go up too high. Huh, I wonder what that spike was. Let's go back into here. See if we can get it to slow down. I'm just going to keep spamming it. Yeah, right here. So it can't be to do with the logs. Or maybe it can, because we're also logging it here, which we don't need anymore. That could be it as well. Let's look at our memory. So yeah, the memory is still high, but it did go down. It probably was way higher than that. Let's actually take a look. So let's just spam it here. Yeah. So it's this right here. So whatever we're hitting, it's checking it. Let's stop that. And let's go check out our user data real fast. Or add contacts. Let's take a look at that. Try this as well. So if object data dot tag dot empty and object data dot group is empty, let's also return false. Because if the object data that's coming in is empty and the tag is empty or the group is empty, we don't care. We'll just leave it. Okay. Let's try running that again. Run it. Oh, still slowing down there. So whenever it's colliding with something, it was slowing down much more before. Oh, there it goes. Slowing down like crazy now. So we got to fix that. We can't be... Well, there's a couple things. It's not going too bad. What did our memory look like? 265. Shouldn't have got that slow for 265. But that helped a little bit. So we're missing something else. Let's get rid of that logger. We don't need that anymore because we're logging into the editor. We no longer need this. We don't need all these, so we can get rid of that as well. Let's do that first. We already have one way that we can do it. Let's check out our logger real fast. And logger.cpp. And yeah, so if we're logging to the console, it'll do this here. If we're retaining log, we do that here. And we also do that in our init function. Let's go to our logger.h. I believe there's an init function for initializing. We do have the init function. Are we calling that? Init logs, yep. And the init function, if we want to console and retain or not have either. And the reason why we don't want to have either is when we actually release the game, you don't want to have any of it. You just want it to, you don't want to go out and take all your logs out, but you just want to not do any of that. So where are we calling this? Let's find it. Just in our editor application. Right now it's true. Let's change this to false. And it shouldn't log to the console anymore. Cool. And let's check our console. Should be nothing there. Yep, nice and empty. Run it. So as soon as it hits that for the first time, it slows right down. So we got to figure that out. So it seems okay. I'm just spamming it right now. So we're shooting our projectiles, no problem. Looks like they're dying, so if I just watch it, yeah, see it just disappears, so it's killing itself. That stuff still works. Let's go check our memory. Yeah, there we go. So see, now we're only at 183. It lowered significantly once, yeah, 157. Significantly once we turn those logs off. So now we don't even really, that's because we're calling print, and that's from Lua. We can actually get rid of that. Where's that? Enter title state. So that would be here in our editor. We have our scripts. Enter title state would be in title state. So game state, title state here. Enter title state. Yeah, because we're calling print, and that's a Lua function, and that's still printing to the console. Let's get rid of that and just go S2D log. Cool. Now that should be logged to our, and we don't need this anymore. So we can actually go into our main.cpp for the editor, sorry. Editor, source, main.cpp. Here, we need to, right now, so we're not debugging, we want to hide the console. And I know how to do that for Windows. I'm not sure how to do that for Linux. So if you know how to do it for Linux, please let me know in the comments and I'll make sure to add that in. Or I'll look up how to do it for Linux and eventually get to it. But for now, we want to hide the console, and we can do that in Windows quite easily. So inside of here, I want to get rid of this now. We can go if def win32. Sorry. Else and right here you can add your add Linux stuff. Yeah, that'll do. And for here, all we have to do is show window, and that is get console window SW hide. Cool. Now, the reason it's looking like this is because we need to include windows.h, and we can just do that here. So we can go here, go if windows, and if include windows.h. And that should hide the console for us. So we can actually copy all this as well. Here. And put it in for show. And that's SW show. And let's run it. All right. So now we don't even have the console. If you look here, the console is not even there to see, which is great. And we're firing. And it seems to be going quite quick now. Let's see if we can get it to slow down. It did. Now, it could be anything. We're going to have to figure that out later. But we are spamming it. We are spamming it with these messages here. So that could be it as well. Oh, no. There it goes. It starts slowing down again. So we got to figure out what that's doing. Let's look at our memory real fast. Yeah, look at that huge spike. Back up to here. So I got to figure out what that's doing and why. So let's do that right now. So let's check something real quick. Let's check our utilities that blew up. And when we're loading the entity, B is sensor. Oh, B is friendly, of course. So let's go back into our projectile defs. Projectile defs. B is friendly. Didn't even add that in. Oh, that's in player def, sorry. And that should be there as well, actually. For the player. Also in our projectile defs. Projectile defs, we called it B friendly. It's B is friendly. Let's try running that again. Awesome. Wow, it seems super fast now. Doesn't seem to be slowing down. I think that's what our problem was. So the issue was every time I shot a projectile, it was touching the player a little bit. And what happened there was the player wasn't friendly and the projectile wasn't friendly. So it was doing all the checks and adding it in and adding it out every shot. So if you're spamming the shots, it was adding the projectile into the checks. See, so here now we're going fast. Let's check out the memory. Real fast. Cool. 171 is its highest peak, and we're floating at 151 right now. Cool. That's the best it's been. So make sure that we made those changes. Okay, I was gonna add some sound in, but this video took longer than I expected. A lot of little nuances that I didn't expect while we were creating it. So what you could do for now is actually go on and add the sounds in yourself, and you can do those here. So if you go to the move state for the character, wherever that is, move state here. And right after you add the projectile, just to do add sound. So what you need to do is go to open game art, grab yourself some sounds, some laser shots or something, and just so it's making like a choo 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 sound whenever you hit the button. So what you could do there for sound, here's an example. It would just be sound.play and then just shot. And it would be 0 because we don't want it to loop, and -1 for the channel. -1 is any open channel. So that's the example to go by. Cool. All right. Now I'm going to be going back and forth between working on this platformer and also working on the editor itself. Okay, because right now we're using Tiled for create our tile maps, which is great. Tile is a great software. I enjoy using it. However, I want to do a simple in-editor tilemap editor for us, so we can easily create tile maps on the fly in the editor. Okay, so the first thing we're going to need to do for that is to create tile sets. So if I stop this, I have this already created in a different version of this. And I'll just stop this here and I will run the other version. The other version has sounds as well. So you can actually hear what's the shots. So this is the other version. And what I want for us, I also have a little mute button there. See if you can get that to work. So you can get it to mute. But anyway, so I want you guys to, this is your challenge, is to create the tile set. So right here, this is just it's loading up this particular. Let's go here and clear this. So it's loading up this particular tile set here, and it's making it all into little buttons. So this is a table, and we're making all these image buttons, and it's just parsing it up to the UV values of the texture. So this is the entire texture here, and these are the UV values based for each button for the width of the tile. And each of these tiles are 16 by 16. Currently in the code, it's hard-coded, but it's going to have to be variable later on. So that's a little challenge for you guys. So create a new display and have it use a table Okay, you want to have an ImGui table, and you need to make image buttons based on the UV values of the texture, okay? And what I want you to do is when you click the button and see how it highlights that particular square, that's the one that we're on. That's what you need to try there. And when you click it, it needs to print the start X and start Y values. So that's your little challenge there. So if we go back here, if we go clear this, and if I hit here, that should be 0 0, right? Go back to the log, right? So it shows 0 0. Let's actually just move this up here so you can see it at the same time in real time. And we go 0 1 or 1 0 2 0 over here. And you want it to highlight the currently selected tile. Okay, so that's the challenge. You don't have to do it. I'll go over it in the next video. So we're going to be going through Platformer and making the Tilemap editor on and off. So a little bit of each for each one. One video will be working on the Platformer. The other one will be working on the Tilemap editor. Now the Tilemap editor is going to take a lot. There's a lot to it, but this is going to be the first part and the first little challenge. So see if you can create the Tileset Display. So that's a new display using a ImGui table. And these are ImGui image buttons. Give that a shot, see what you can do. All right, that's it. Take it easy.